we would do is we would change this and say this is 1. This becomes 1 over sine. Secant is what? 1 over cosine. Minus cotangent. Yeah, but that's not in terms of sine and cosine. Cosine over now, you have 2 chunks that are in fractional form. So to add or subtract those things, we need to have a what? Common denominator. What would be the common denominator here? Sine, cosine, right? So I need to multiply the second term by what? Don't I need to multiply by cosine over cosine? Why does multiplying by cosine over cosine work? What is cosine over cosine? 1. Can I multiply by 1 and not change anything? Yes. Anything multiplied by 1 is the same thing, isn't it? So to get a common denominator, that's what I'm going to do. So now I'm going to rewrite this as 1 minus, what is cosine times cosine? Yep. All over that common denominator. Now, remember what I said, basic identities. Those are our quotient, our reciprocal, and our Pythagorean, right? Don't we have a Pythagorean identity that looks sort of like this? It's got a 1 and a cosine squared in it. It doesn't look exactly like that, does it? Guys, you've got to be able to manipulate those formulas. What does the formula look like that we know? Yep, sine squared plus cosine squared equals 1. But I have 1 minus cosine squared. So can I turn that into 1 minus cosine squared? Yes. By just subtracting, moving cosine to the other side? Yes? Doesn't that go away? Do you see what I mean about you got to be able to mentally manipulate these things? So what is 1 minus cosine squared equivalent to? Sine squared. So that's the next step here. 1 minus cosine squared becomes now, are you starting to see where maybe I can do something else? Can I get rid of anything? What do I have? This is all one fraction now. No minus sign. What do I have in the top and what do I have in the bottom? I got sine times sine here and I got sine here. So I can get rid of this along with the squared, can't I? So sine goes away. So what am I left with at this point? Ah. Yep. Which equals, and I believe that is 1 trig term, isn't it?
Yes.
So do you see how we took this big long string of trig terms? It's like a puzzle, guys.
Is that the end of the problem?
Yeah. We simplified it. We got it down to 1 trig term. We're done. It can be. This is what we're doing.
It reminds me of that factor and stuff we had.
This is like
Kind of, sort of.
like a puzzle.
It is a puzzle. And if you think about it as a puzzle, guys, look. These things are going to do one of 2 things for you. They're either going to frustrate the fire out of you, and you're going to therefore hate them and not be good at them, or you can look at them with a good attitude, which is, this is kind of like a puzzle, I want to figure it out, and they'll be kind of fun. Because you'll get better at seeing where you have to start. That's the hardest part, is where do I start? Which is why I'm giving you techniques. The first technique was turn everything into what? terms of sine and cosine. So that at least gives you a place to start. So let's look at another one. Cosecant y over cotangent y.
Why did it seem so easy?
I know that's because I have experience doing this, and I love these. This is like one of my favorite things to do that we do all year. I love these things because they're fun. They're like a puzzle. It's like a math puzzle that doesn't have numbers.
Oh, this
I mean,
is
what's
what
not
you
to
had
hate?
with the math with no numbers.
Yeah.
Actually, there are numbers.
What is cosecant?
1 over sine.
Okay, so cosecant's going to turn into 1 over sine y. And that is going to be divided by, and I don't like compound fractions, so I'm going to write it sideways. Smart, right? Cotangent y is what?
No, sine over.
Cotangent is cosine over sine. Tangent is sine over cosine. Now, instead of dividing, what can we do? By the, so 1 over sine times, what? What's the reciprocal of that guy? Sine over cosine. And now what can I do? Get rid of the sines. So I'm left with,
It's
very
This
good.
one's easy.
Yeah.
First one, this one.
All right. Look at example. Huh?
They all lead to like somewhere.
They all lead to sine, cosine, tangent, cotangent, one of those like that. That's what we're talking about with one trig term. I know, it is kind of crazy. All right, try this one. Tell me what you think you might, what's a good strategy first? What do you see here? Okay, put it in terms of sine and cosine. You can.
Can we divide? No, not divide.
Not divide, but I know where you're going.
You have to move that secant x to be this secant x so that you can like split it or something. They're the same.
You can't square it, but they're in both terms. So how do you divide out a term? What's that called when you divide it out and pull it to the front? The opposite of distributing. Distributing is where you put it in. What is it when you pull it out? Starts with an F.
Oh,
Factoring. We gonna factor out what?
Be for real.
secant.
Secant.
Factor out.
We got a secant in both terms, don't we? So secant x, what am I left with inside?
Actually, I like
Sine
that.
x, sine squared x.
And? Oh, look at that. Sine squared minus 1. How can we get sine squared minus 1 from, what do we know?
Sine squared plus move cosine.
Move cosine to the other side and move the 1 to, if I move this over here and that over there,
It's sine squared minus 1.
Sine squared minus 1.
equals what?
Negative cosine squared.
Negative cosine squared, isn't it? Because I had to move the cosine to the other side. So that's what I can put in here. I got secant of x times negative cosine squared of x. Now, I got to figure out what to do with that secant, because I still got two terms here.
It's 1 over cosine.
Ah. So this is 1 over cosine times negative cosine squared. So now what? I got cosines in the bottom and cosines in the top.
Oh, cross them out.
I can cross this out with one of those, can't I? So what's my final answer?
1 over
1 times negative cosine of x is just negative cosine of x, isn't it? All right. Last one here.
Wait, what did you write?
What did I write? What?
Oh, I'm sorry, I got it.
I should go for Whiteboard.
I went from, just so everybody knows, can follow, I took this and replaced it with that. I then took this and replaced it with that. Does that help? That became that. That became that. And then I marked out one of the cosines. Do you see it?
Yeah, he was talking about it.
Oh, okay. All right, number 4. What is cotangent of pi over 2 minus x? Look on your sheet. How do I know that I need to be looking at the cofunctions?
Tangent of pi over 2 minus 3. I mean,
Cotangent of pi over 2 minus x is what?
That's tangent.
Okay, so I can replace this with tangent of x, cosine of x. Now what?
change
Tangent becomes what? Yep.
Is it y over x?
Mm-hmm.
Would you look at that? Cosines, exact.
Mm-hmm.
Why are these so easy?
Those are the basic. Some of them are easy, some of them are tougher. I'm not gonna give you all easy ones and then have you find tougher ones on your homework and be like, Ms. Duff, you just gave us all easy ones.
But I got a question. On the test, we don't have to memorize all these, right?
No.
Oh, okay.
We only have to, we
I'm
have
about
to
to
do.
say, not, like,
No, you'll have I gave you a formula sheet.
I know, I got it.
I know, you letting us keep have to set up when we talk about this?
Yeah. I don't expect you to memorize them all. I don't have them all memorized.
That's why you go.
All right. Factoring. What do I mean by factoring? Couple of things. Tangent squared x minus 1 is the difference of 2 squares, isn't it? What do we remember about a squared minus b squared? It is what? A plus b, a minus b. Do you see how that would help us in this first problem?
Mm-hmm.
Yes. So tangent squared of x minus 1 can be factored into what?
Tangent x.
Yep, tangent x minus 1, tan x plus 1. All over.
That x, is it just theta?
Yeah, theta, x, u, whatever. Just use the variable they give you in the problem. I change it up because it changes up in the books and stuff. I don't want you to think it has to be theta.
And then you cross out the 2 pluses.
Cross out this and that. So what is the answer here?
Tan x minus 1.
Yep. Which we can't do anything with. But that's one trig term, isn't it?
Mm-hmm.
Just tangent, so that is our answer. Now I'm going to change this one up.
Yeah.
So we're going to do one more of these, and then we'll move on to the next ones.
previous?
Well, before we can factor though, do you see that sine pi over 2 minus x? Ah. So if we replace that, now do you see where we're going to be factoring? What am I going to factor out? Okay. And what's left inside? Minus 1. Don't forget that minus 1. Now, what is sine squared minus 1 equal to? Equivalent to? We just saw that earlier in one of the earlier problems, didn't we?
Negative cosine.
Ah. So what would the final answer be?
P.
Yep. Negative cosine cubed of x. These are not all going to be the same. As a matter of fact, everyone's going to be different. We're going to skip that one. Let's Pythagorean identities. Pythagorean identities. We've got a place where we can use a Pythagorean identity, don't we? What Pythagorean identity can I use right here?
Tangent theta plus 1 equals secant.
So secant squared is tangent squared plus 1, isn't it? So this becomes tan minus there's a lot of tangents in there, isn't there? Now, one of those pieces is a fraction and the other piece is not, which means we need to get a what?
I mean,
Common denominator. Anytime you have two fractions like that, you've got to get them put together. All right? So what's the common denominator going to be? Tangent. So what do I need to multiply and where? Don't I? Why? So they're both over tangent. So what is tangent times tangent? Tangent squared. So now I have tangent squared minus tangent squared minus 1. Why do I do minus 1? Notice that this is all on the outside, isn't it? So we got to distribute that negative in, don't we? And it's all over what? So what is tan squared minus tan squared? So, negative 1 over tangent, which is what? Yep. Negative cotangent. All right, we're going to get rid of this one and put a different example in. Let's do, instead of that one, let's do anybody want to give me a hint as to what you think we can replace? And Anytime you see a squared term, you should be thinking Pythagorean identities.
A plus sine squared.
Replace sine squared with what? It would be negative cosine squared plus 1, or it would be 1 minus. All right, so this becomes 1 minus. Now, 1 minus cosine squared, you cannot just pull 1 minus cosine out of it. That is the difference of two squares, isn't it? So how do I rewrite 1 minus cosine squared that will help me? 1 plus cosine
Oh,
and then what happens? So what's the final answer to this one? 1 minus, what plus cosine y? Yep. All right, got a little bit of time left. Let's do a couple more. Let's talk about getting rid of fractional form, then I'm gonna let you try a couple here in this next little set. Getting rid of fractional form, because remember, what did I say? One of our rules was we can't have things in the denominator. 1 minus sine, you can't replace it with anything. It's not 1 plus sine squared or 1 minus sine squared. It's not squared at all, is it? So how do I get rid of 1 plus sine isn't anything, but 1 minus sine squared is, isn't it? 1 minus sine squared is cosine squared, right? So I'm going to use that idea and turn that 1 plus sine into a 1 minus sine squared. The way I'm going to do that is I'm going to put the other chunk of its difference of two squares in. I've got 1 plus sine, so I need this becomes tangent of theta plus cosine times 1 minus sine and just to not skip steps, this becomes 1 minus sine squared, doesn't it? All right. What did we say 1 minus sine squared was equivalent to?
1 plus sine, 1 minus sine. I mean, no.
Pythagorean identity says it's what? Cosine squared, doesn't it? So now I want you to think about this. This is tangent theta. We got cosine here, 1 minus sine here, and this is now becoming cosine squared theta. Now, I got a cosine in the top and a cosine in the bottom, don't I? So this goes away and one of these goes away. Now I still have two chunks to this, don't I? That tangent I haven't done anything with yet because I didn't see what I could do, but now I can, because what is tangent? Sine over cosine. So now this is sine over cosine. And this is 1 minus sine over. We actually have a common denominator here, don't we? All over now what? Sine, positive plus sine minus sine, what happens? So I'm left with what? Which is secant. Guys, you've got to learn a couple things. You've got to get a common denominator. You've got to be confident in how to get a common denominator, because a lot of times we'll have common denominators. And you've got to look for those clues, like how to use the Pythagorean identity, things like that. I know we don't have time for all the rest of these examples because it's 1:25 already. Time flies, doesn't it? So I want you to try one simple one. Try number 2. See if you can figure out where to go with this. When in doubt, put everything in terms of sine and cosine. So try number 2 and see if you can get it down to one term. I'll even tell you what it's going to be. See if you can get it there. Guys, you get a bunch of these to try.
Can I get like a brain card? You know what I mean, but what I guess like
get this right away, guys, do not flip out on me.
Miss Duffy, I'm confused.
It is okay. You just try it. Next time we will be looking at doing more. You're gonna get a lot more practice on it. Okay.
You just flip the thing,
Cozy,
He's bothered.
Oh.
you keep moving it up the way.
You wanna know what was
Cozy
left?
is
He's gonna show you what.
cosine over. Yes.
We just had, we just finished the notes, and then homework is.
I think I gave you the assignment last time. Didn't I give you the numbers last time? Time before last? Chapter 10 is.
How'd y'all doing your, were you at
That's
10?
that kind
Oh,
of thing.
I was at tennis, and you and Carly were on the beach.
I was skiing. Beautiful.
Since sometimes my mom be reading them as cozy, scent, or like tense,
Are these the ones we do, Miss Duffy?